Okay, so let's get started for the day. My plan is to talk about the first, not the first, the fourth and the fifth questions on the reading guide that we didn't get to do. So we're going to do that first, and then hopefully it doesn't take long. And then we're going to move to the video that you all watched. There are certain things I want to talk about. I mean, so we can either talk about it after we cover the hierarchical model that I prepared, but I feel like everybody was watching it yesterday, so probably you're pretty onto the material, so we can go through that quickly. I don't know, we'll see. And then if we have extra time, we can cover the material that I have, but I doubt we're going to have it, but let's see how it goes. So the plan is, first of all, we're going to talk about the discussion questions. Yes. Okay. Right. So if you remember what we're doing, we are reading that paper together, and then there are a couple of questions that we didn't get to talk about. One of the questions is this one, and a little bit tedious, and I don't see many responses, so that was the reason why we didn't get to talk about it before the break. But it's still nicely done because it's a 2x2 case. If you remember what they do, they have binary outcome for x and y. So okay, probably what I would do is I would start with the construction that they have on the screen, and then I would do a couple of demo of say what is the marginal distribution of y, and then and of course the paper actually gives you what the marginal distribution of the x. So if you have access to the paper, you might want to put it out on your screen if you want, but I'm going to write some of the key steps here. And so the general story is we have a 2x2 binary outcome of x and y, and we're trying to make sure that we can say, first of all, understand what are those transitional, I think that's what they call it, transition matrices, right? Like a y given x is transitioning from x to y, and then the other one, x given y, is transitioning from y to x. So those two actually are given to you in the paper. So I'm going to write them out on the screen. So so if you read the question carefully, you have to first of all write down the marginal distribution of y and verify that you can go from x to y through ax given y, and you can also go from y to x with ax given y. And so that's just matrix manipulation. You have to, I mean, again, linear algebra is required for this course, so hopefully it's not too much. And the last part is verify ax given x. So that, by reading it, might be a little confusing, but the paper was talking about from, like, say, x0 to x1, right? Because you go from x0 to y1, and then y1 to x1. So what you can do is, so first of all, you have to verify ax given x equals to the multiplication of these two. So again, ay given x and ax given y, both of them are 2x2 matrices. And so you do 2x2 matrices multiplication. So very tedious, but it's doable. And then you have to think a little bit harder about how to express ax given x. So my suggestion is thinking about from the previous time point to the next time point. Okay, so x0, for example, to x1. Okay, and then lastly, that whole thing, fx, ax given x. So that's just transit. So fx, remember, is the marginal distribution. Okay, it's the distribution that we're trying to approach to, and this is saying that ignoring the middle point, I mean middle part, you're going from fx. You're using the transition matrix from x to x, you're going to go back to x. Okay, so that's what it is. But of course, there are some details involved. So I don't think we're going to do all of them, but I do want to do a little bit of demonstration of what you can do with this simple, discrete 2x2 case. Okay? And then the paper went on talking about how about it continues, how you're doing those integrations. So those left it for you to study or like to digest. So let me just write a few things to start with, and then use some time to think through. And okay, so what's given in the paper? So the way that they write it, you notice, is the joint. So remember, it's binary 2 by 2. So, oops, so it should be 1, 1 here. Right, so that will be the matrix that you have. It's 2 by 2, and we're writing it as a joint. So you have fx, comma y. Okay, and what's in the parentheses is just the outcome of each of these two, each of the four. And what's given to you is those probability. So this is the starting point. This is the joint. Okay, this is the joint. And what we know is from the joint, you can write the marginal. So we know that if you want to get, okay, so this is, if you want to get like fy, give from the joint, what you do is you, in this case, it's disjoint, it's discrete. So you're going to sum over all of the x, right, of the joint of x and y, right? This is from probability courses you have taken before. And of course, in order to get the marginal of x, you sum over all of the y from the joint. Okay? Yeah. So what's the marginal of x then? You will just be looking at all of the cases that can make x 0, and all of the cases can make x 1, right? And essentially, you're just going back to this matrix and then finding the correct terms to add. Okay? So what should be fx 0? I should be looking at this column, right? So it's going to be P1 plus P3, right? And then the other one, fx equals to 1, will be the second column, will be P2 plus P4. That makes sense? Okay. Yeah, so how about the margin of y? First part of the verification. So instead of looking at columns, we look at rows, right? So again, this is a 2 by 2 case. It's easy to deal with. You always go back to the joint and then find the correct terms that you need. Okay? So this is what, P1 plus P2, and then P3 plus P4. Okay? All right, that's good. So that's the first part, write down the marginal distribution. And I want you to try to, this is tedious, but it's still worth doing, verify the conditional probabilities or the transitional matrix of a, let's do y given x. Okay, so it's given in the in the paper. So let me write it for you. What's given? You can always compute it from the joint, okay? Because the conditional is the joint over the marginal. And what we just did was the marginal, right? So you can pretty much, so you can imagine this is going to become the first term divided by something, right? Yeah. So I'm going to just give it to you, and I will ask you to verify that it is the transitional probability. So, and the second is P2 over P2 plus P4. And then this is P4 over P2 plus P4. Okay? So what do we mean by verify? We know what it is, and we need to verify it is indeed the transitional matrix. Okay? So in order to show that it's a transitional matrix, it's what? It's transitioning from x to y, right? So what you should have is if you multiply fx with this matrix, should give you what? Transitioning from x to y. So it's going to give you the margin of y. Okay. Yeah. So just quickly try to do this algebra work. It's a vector multiplies with a matrix, gives you another vector. And we are given the margin of x, margin of y, and then this transition matrix. Okay. So try to do that really quick. I think it shouldn't be too hard. And then the other one, the transition matrix, the other one is similarly done. Okay. So I'm going to pause here for a few minutes and yeah, just get us started for the material. This is a long break. Really quickly about the verification and let's see what I can bring. Evaluate everything. Well, yeah. Okay. So what we have, we are trying to do x multiply with the transition matrix y given x, right? So we're trying to verify that this is going to give you the marginal of y. Okay. So the left hand side is, so the margin of x, you should have it with you. So I'm just going to write it here. So it's P4. And then multiply with this matrix. The matrix is P1 over P1 plus P3. Right? Yeah, so for me, I always try to make sure like the dimension works. So this is 2 by 2, this is 1 by 2, so I should have a 1 by 2 in the end. Okay, and then to do the multiplication, you go, I mean, the row times the column, the row times the column, right? So you're gonna have, well, you can probably read it off because when you have P1 plus P3 times this term, it's gonna give you P1, right? And then when you have P2 plus P4 multiplies with this term, it'll give you P2. Okay? That's the sum of these two. Okay? And similarly, P1 plus P3 multiply with this, gets you P3. And then this multiply with the last term gives you P4, which is the right-hand side, because we just, earlier, we had it before. That the margin of y is what's here, P1 plus P2 and P3 plus P4. Okay? Yeah, similarly, you can do that for the other case. So so I will leave that for your interest if you want to do it later. And let's just try to do another one really quick because I think this one is a little bit more complicated to do. So what this is telling us, we were saying, is you transitioning from x to x might not be easy to think about, but you can think about x0 to x1 or xk to xk plus 1. Okay? And this one, we know it's a 2 by 2 matrix multiplied with the 2 by 2 matrix, right? So you're going to come up with another 2 by 2 matrix, which is very tedious to do. But once you come up with that, try to think about how you can link it to this ax given x. Yeah, because once you do that, like I said, you're going to get a 2 by 2. It's going to be a bunch of P1, P2, P3, P4 together in a weird situation. But how can you verify that it equals to if you are doing transition, two-step transition from xk through yk plus 1 to xk plus 1. Okay. So I would suggest you to write out the right-hand side first. It's just going to be complicated large, but I would suggest you not to try to simplify anything. Just put it together. It might be easier to see of the result later. So let's spend a few minutes on this. I will start writing on the board as well of the right-hand side. I wrote down, I mean, it's just repeating. We're just doing the multiplication term by term. But this, I was suggesting not try to simplify it too much. So just leave it in the way it is. And you should arrive at a 2 by 2 matrix in this way, which represent the right-hand side. So double check you have something at least similar, hopefully exactly the same. And so with this, we have to verify how can this be equal to a x given x, right? Because we don't know the expression of a x given x, right? By doing the transitioning, because of Gibbs sampler, you do one parameter at a time and then the next parameter and et cetera, you only have 2 parameters in this case. So you're going to get back to your x by doing multiplication of 2 conditional terms. If you have multiple parameters, you just keep adding them in between, multiplying them in between, right? If you have more parameters. So now, we don't know the expression of ax given x. But think about what can we simplify, like certain ways to simplify this to some extent. Okay? I was saying you can think about previous x to next x. So you can do like x0 or x1 or xk or xk plus 1. So whichever you do, I mean, just pick one. And my suggestion to you is think about the possible values of x's, right? Because after all, it's all binary. Right? So you can think about when x is close to 0. Of course, there are 2 x's here. So what does it mean to be conditioning on x equals to 0? What does it mean to have x equals to 0 before the conditional sign? Okay. And then try to verify that you can, I mean, all of those terms, the 4 terms here in this 2 by 2 matrix is conveying that information. Okay. Yeah, so I'm going to pause here a little bit. It's some stretch of thinking, and I'm going to give you a hint. Once we do that, we're going to move to the new material. So one thing to think about, I mean, well, we know this ax then x should be 2 by 2, and we're transitioning from previous x to next x. So what do you think the first term of this 2 by 2 matrix is representing? You think about previous x, let's just say x0 and x1. Okay, let's think about from x0 to x1. That's for the entire matrix, right? And then for the first item, what it means, it should mean, because we're transitioning from x to x0 to x1, and in particular for this location in this 2 by 2 matrix, you're transitioning, I think, of x0 equals to 0 to x1 equals to 0. Right? Yeah, so again, it's binary. So earlier we're talking about x and y to be binary 0, 1, 0, 1. So you have the, I mean, all of those transition matrix as well as the joint. But here, this is a conditional distribution. right? The conditional matrix right now that we're dealing with, AX given X. And then you can still start to think about at each different position of this 2 by 2 matrix, what it is representing about the values of X0 and X1 that can take. So I'm saying that the first term should be transitioning of X0 to 0, X0 equals to 0 to X1 equals to 0. So essentially, we're trying to verify, I should say, whether this probability, the sum of two products here, it is expressing the probability that X1 equal to 0, given that X0 equals to 0. Does that make sense? It's conditional, and it's transitioning in the context of the Gibbs sampler that we're doing. So I'm trying to find out the conditional probability of X1 equals to 0 given X0 equals to 0. And that should be my first element in this matrix. So if you get that, let's look at the term a little more carefully. It's the sum of two products. So how that can help us? I mean, think about the format of this to see how. I mean, obviously you have to break it into sum of two products, and what are those products mean? So keep in mind that here we're doing from X0 to X1 directly, right? But when you're doing the transitioning, the sampler is you go from X0 to Y1, and then from Y1 to X1, right? So another way to write this, I mean, pretty much we're trying to break it down into the form that we see in this first element in the bracket, I mean, in the red box, is what would it be if I transition, I mean, I have to go through Y1, right? And Y1 can take what? Two kinds of values, 0 or 1, right? So there are two ways that I can go from X0 equals to 0 to X1 equals to 0. One way is going through Y1 equals to 0. The other way is goes from Y1 equals to 1. Okay, so let me just write it so it's probably easier. So this is the case that right? This is one way that I can get X1 equals to 0 given X0 equals to 0, because I go through Y1 as Y1 equals to 0. And another one, as you might be guessing, is Y1 equals to 1, and Y1 equals to 1. This again is the law of total probability, because when you, so this is the joint, right? This is the joint of X1 equals to 0, comma, Y1 equals to 0, condition, X0 equals to 0. The second term is the joint of X1 equals to 0, comma, Y1 equals to 1, given X0 equals to 0. And you add this two up, because by law of total probability, I'm summing over all of the possible values of Y1 in this case. And then I will get my left-hand side, which is the conditional X1 equals to 0, given X0 equals to 0. And you do that for all of the four elements. And then you're ready to justify or verify the results. Okay. Well, I know it's a little tedious, but I still think it's important to grasp. I mean, because for Gibbs sampler so far, we've been talking about like the general framework, how to do it. Of course, we talked about how to do the diagnostics, et cetera, but it's also very important to know how it works or why it works, I would say. And then for this 2x2 discrete binary case, you can enumerate all of the cases. So you can work with this 2x2 transition matrices, et cetera, so you can verify. So we're not going to do this, but this is very, once you get the AX given X, I mean, in this form, you just like keep applying the multiplication, you will see the results. But I do think this part is important to grasp. Even though we know it should work in this way, that's how the example works. But how to verify it in the simple case helps us, I think, to understand how those transitioning is happening. In practice, I mean, especially soonish, we're gonna all start using JAGs, so you don't even need to get into all of the details of how deep sampler is working. But it's, I think, very important to know how it works and why it works. Because in the end, once you do all of those models, you want to summarize your results, right? And what those results mean, what kind of message they convey. I think Josh did a really good job in his video talking about, I mean, I don't know if you noticed at the end, talking about all of the results. We will start talking about those as well, how to summarize them, what do they mean in the context, et cetera, et cetera. So those are important. And then knowing how the sampler works, I think helps you to know why. I mean, don't treat JAGs as a black box. You know how it works, especially if it's a Gibbs sampler, like what we're doing now. If you were to code it yourself, you can. It's just more tedious to do, and then maybe not as efficient. But you can always do it if you know the full conditional distributions that we've been talking about so far. And yeah, so that's the part that I want to cover. Hopefully it's not too boring, but hopefully it's useful to some extent. Okay. Any questions? Okay. All right, cool. So stop this.